Hello Future Peas, this is Wasim Asghar. I'm a licensed professional engineer in the US and Canada. I've authored several books on the topic of FE Electrical and Computer Exam and the PE Power Exam. I also run popular programs for FE Electrical and Computer Exam preparation as well as the PE Power Exam preparation. In this video, I'm going to go over questions related to trigonometry that I received from a student during one of my live training sessions for FE Electrical and Computer Exam. As you probably know, trigonometry shows up in mathematics and it's part of section number 1, math. Math is one of the big 5 topics. Roughly about 10% of the exam by weightage is contained in mathematics. It is also important because it shows up right up front in your exam. So if you put yourself in the shoes of an exam taker who's about to start the 5-hour and 20-minute long exam and is presented with 10, 11, 12 questions from mathematics, if you are well prepared for this section, then your confidence is going to go through the roof as you progress along with mathematics and get every question right. And this sets you up for success for the rest of the exam as well. That's why I pay special attention to mathematics and tell my students to actually put in a little bit extra time and effort in maths. Throughout my program, I use a first principle problem-based learning approach, which helps students get a good handle on theoretical concepts as well as tons and tons of practice in the form of quizzes, in-lecture practice problems, mini exams, and computer-simulated practice exams within my program. If you're new to this channel, then please consider subscribing to the channel in order to stay up to date with the weekly content that I publish related to FE Electrical and PE Power Exam preparation. Without further ado, let's dive into the content. And if you want to learn more about my FE Electrical and PE Power Exam preparation programs, please visit my website, www.StudyforFE.com. Without further ado, let's dive into the content right away. So I'm glad on the very first that I was able to catch this on the very first problem, but it was not automatically recording. Yeah. So when it comes to trigonometric identities, the important thing is that recognize in the reference handbook, you have more than 30 identities, right? And it will not always click with you right away. So it will be a little bit of a trial and error. So even in the on-demand and even in the live training recordings that you guys see, I have pointed out that there are a handful of identities that are extremely useful and they come up over and over again, right? So you have the Pythagoras theorem, which is sine square x or sine square theta plus cosine square theta is equal to 1. The double angle formulas are very helpful as well. They will show up a lot more in communications and signal processing down the road, right? Those are the sine 2 alpha is equal to 2 sine alpha, cosine alpha, basically roughly on in the top half of the identities that are given in trigonometry. Then you have cosine 2 alpha. That is also a very popular formula. And then half angle formulas. So just remember to go through, scroll through, eyeball, whatever you want to call it, skim through the identities that are given there. Now, between the questions that you have, practice problems that you have in the in-lecture practice problems, the quizzes, the mini exams, the study guide problem sets, the homework assignments, I've consciously tried to make an effort to give you an exposure to, if not all of these trigonometric identities, at least 80-90% of them are covered, okay? Any questions about this, guys? Any concerns? Can we move on? Any doubts? All good here? All right. So the next question I received was mathematics quiz problem number 5 from trigonometry. So quick question, I don't understand why answer to question number 5 is not 2 sine square 2x. In line 4 of the solution, wouldn't you need a constant value of 2? So essentially, I was asking in this quiz problem to simplify this. 4 sine square theta cosine square theta. Now, one of the things that you guys need to remember when you're dealing with trigonometry, especially simplification of different functions, is that there can be several steps where you can stop, okay? So you always have to keep an eye on what are the options that are given to you, right? So this is a solution that I provided. So I have 4 sine square cosine square theta, right? So the way that I approached this in order to make it compact was that let's take a look at the double angle formula. The double angle formula is sine 2 theta, right? So that's 2 times sine theta cosine theta. So if I multiply sine 2 theta with sine 2 theta, I end up with 4 sine square cosine square. Is that clear, guys? Okay, so sometimes you actually have to look at the options that are provided to you and then make your way, sort of reverse engineer it, right? And again, in this case, the identity that came to our rescue was the double angle formula. Okay, so please review the 30 plus trigonometric identities, and of them, these are arguably some of the most important ones. If you have any questions, any concerns, please let me know. All good? I'd appreciate if you guys can provide me feedback so that I know that, it's clicking with you and you don't have any concerns, and that we can march along. Just a simple yes or no or a quick question, that would be greatly appreciated. Okay, pretty simple, straightforward here. All right, let's go. The next one, dealing with trigonometry over here as well, is that the student asked me this question. And again, for a lot of you guys, maybe these are very basic, simple, straightforward questions, right? And I think the real learning happens when, with the commentary, the feedback that I'm providing, right? Under which law we can simplify the expression? So again, the common thing that I notice with these type of questions related to trigonometry is that students feel like if I go to the trigonometric identities on page number 38 in the reference handbook, some line item is going to scream at me and it's going to say tangent square theta plus 1 is equal to secant square. So it's going to be a grab and go, right? It's not always like that, right? So if I have to prove that a tangent square theta plus 1 is equal to secant square theta, I can take a couple of different approaches, right? So the most fundamental approach would be, let's see what tangent is made up of. What is tangent made up of? Tangent is made up of sine theta divided by cosine theta. So that's my tangent theta. Now, if I want to make a square of this, right, then I'm going to put a square here, a square here. Is that clear, guys? Make sense? Right? And then I'm adding 1 to it, right? So if I add 1 to it, then what does it become? It becomes, again, the denominator is cosine square theta, correct? Sine square theta plus cosine square theta, right? Yeah. And then this guy in the numerator is what? This guy in the numerator is Pythagoras theorem, right? The famous Pythagoras theorem that will show up again and again and again in trigonometry. This is equal to 1. So 1 divided by cosine square theta is basically 1 divided by cosine theta whole square, and 1 divided by cosine theta is equal to secant theta. And don't remember the square that is here, and that's how you end up with secant square theta. Make sense? Okay. Any questions? All right. The next one on trigonometry. I have downloaded NCS reference handbook version 10.4 as of July. I'm planning to use this. In trigonometry section, you said NCS reference handbook has identity. So again, this is the identity I think the student was questioning. So I think you were there who asked this question. And the comment that was made was that Wasim, just let the students know that some of these identities are not available directly. You will have to work around, and that's 100% true. So the key over here was that recognizing that cotangent x is actually equal to 1 over tangent x, right? So you actually have to make use of this, and then you have to make use of this. Okay. So the identities that you may require may not be available to you right away, right? And be comfortable in sort of the trial and error methodology with trigonometry. And to be honest, 3 minutes per question for something like this, even if it does not click right away, in my opinion, is more than enough. Okay. All right. So does it make sense, guys, what is going on here and how we had to sort of identify first cotangent is 1 over tangent and tangent is sine over cosine. So it became cosine over sine. Remember that there's a square and then adding 1 and base multiplying with, sine square, and it basically got simplified. If you like this video, then please don't forget to subscribe to this channel. Feel free to ask me any questions in the comment section of this video below. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.